Okay. Hi, everybody. This is Dance Dance MeeGo Revolution. I first want to thank you all. I know that I'm pretty much the one that's separating you from going back home. I know I'm dead last, so I'll make this as quick as possible, but as entertaining as possible. So I'm making the assumption that you know a little bit about QML, what is MeeGo, a little bit of JavaScript. If you don't, well, enjoy the pretty pictures. So first is, who am I? I am Tej Shah. I am an engineer at ICS. And now the DDR pad is not working anymore. I'm a gamer. I've been gaming since I was 4. I've been a software engineer since I was in 6th grade. And I'm an employee of ICS. So you're probably thinking, who's ICS? We are the largest Qt consultants in North America. We can help you make your Qt app. We can help you debug your Qt app. We can help you do parts of your Qt app. We can even train you how to make your Qt app. Pretty much anything related to Qt, we do. Even if it's Qt on Symbian, Qt on desktop, Qt on MeeGo, all of it. We have actually training videos on our website you can download on MeeGo, Qt, QML, and so on. So if you haven't heard of DDR, well, I guess then this is not as interesting, but I can assure you it's a really popular game back from 1998 till 2005. They're in arcades all over the country. It originally was started in Japan by Konami, and then it came to the US and many other countries. I even saw it in random places in the middle of nowhere. India, it's really popular. And then around 2005, it just kind of died down a little bit. But thankfully, afterwards, there was Stepmania. It's an open source implementation of DDR. And it's a great game. Works just like the original, but there were a few problems. One is it was already in C++. There's hundreds of thousands of lines of code, so if I wanted to actually make any change, I'm more likely to screw things up than actually do something useful. And also it used OpenGL for the desktop. So if I want to do it on an embedded device or use something that's not really OpenGL, well, then I'm out of luck. So I decided to actually implement a version using QML. So one of the nice things about QML is that it can actually use OpenGL ES 2.0. So yes, it can work with nice smooth transitions and nice animation on your phone, a BeagleBoard, or whatever kind of embedded device. So anybody could have done this, let's say using Q graphics view, C++, just use the animation framework, and then you're done. So that wouldn't have been as interesting of a problem to solve, if anybody can do it. So I thought, I'm going to do one extra step. No C++. Now, why would I torture myself in doing that? Well, QML is supposed to be the future of MeeGo. Everything in QML. You can do anything in QML. So if you can't make a simple game in QML, then can we really say that QML is really the future of MeeGo? I mean, all of you here are for MeeGo, and to say, okay, the future of MeeGo is QML, and QML can't do much, well, there's a problem. So, in QML does have its advantages. For animation, let's say you want to move an arrow from bottom to up, there's already an animation framework. You can set the duration. It can also handle a lot of different types of animation. Let's say I want to make an arrow flash, or if I want to change an arrow's image to another image, so on. It's actually fairly easy. So I thought, doing a QML implementation kind of sounds hard at first, but maybe it can be done. So here are the 4 questions I really wanted to answer in making this proof of concept. And the answer to all 4 of these questions are pretty much the same, which is yes! But, so there's always like, yes, I can do it, but then there's something else you have to keep in mind when doing it. So can you actually make a game using QML? The answer is yes, you can, but there's a lot of problems. So I was able to make this proof of concept. It's all QML using JavaScript, no C++ backend, and it works. And when I actually was thinking about what kind of games can I really make using QML, I was thinking, okay, maybe a Street Fighter game or maybe some kind of RPG. And every time I was thinking about new ideas of games to make in QML, I found something that's really missing in QML that really stopped me from making pretty much most of my ideas. And that is really collision detection. You need to have something that says, yes, that hit that person. Yes, the ball went from there to there. Yes, it went through the goal and not into the crowd. Without collision detection, there's very few games you can actually make in just pure QML. I mean, even like solitaire. You get a card here, get a card here. Oh, wait, I have to know when the card is actually over another card. You can say, okay, on X changed, but then on every time the X changes, I have to do calculations, and that's very complicated, and I'm more likely to mess up than get it right, and probably going to be quadratic. Yeah, it's not that easy. So can QML/Qt handle different types of inputs? Yes, it can. I got it to work on my N8 without any code change. I can just get it to work with the thumbs. I can even do the N8's, be able to hook up a USB keyboard and make that work without any code change. But the problem I had was the fact that QML doesn't support joystick. When you buy these pads, they actually come up onto the Linux kernel as /dev/input/JS0, meaning joystick 0. This is not a QML problem. This is a Qt problem. Qt does not support joystick. So you're probably wondering, how the heck did I actually get this to work then? Well, what I used was a program called JKeys. It's a simple Python script, runs in the background, and when I launch my app, it launches that as well, and then says, okay, whenever you see joystick button 2, that's really the up button. And that's actually a nice thing about MeeGo versus, let's say, just QML by itself. If I was just stuck with just QML, I wouldn't have been able to solve this problem. But since MeeGo allows so many, Python or Perl and Bash, I was able to solve this problem pretty easily. Hence the reason why this is Dance Dance MeeGo Revolution, not QML Revolution. So can your QML application run well when you have lots of animation? So I actually did a stress test at the very beginning of the project. Had hundreds of arrows, 1080p video, and had the arrows moving around and lots of animation happening, and it was still running at 30 frames per second. I was like, wow, that's pretty good. And then I was told, hey, there's that dash OpenGL option. I was like, oh, ran it again, 60 frames per second. It's like, yes! And then I started using JavaScript, which I'll talk about later. There's this kind of idea, this promise of QML that, okay, all the artists, they all do the hard work of making all the designs, they do all the animation, and then a guy who's sort of a programmer but not really can just put it all together, and then bada bing, bada boom, you're done. Yeah, QML kind of supports that, but the problem is that the artists have to know more details about what the game is going to actually look like, what platform problems you're going to have, and they have to know what kind of format you want it in. So when I made this game, one of the ideas was, I don't need to do any artwork. StepMania did all the artwork. I just can steal all their, PNG files, all their artwork, and I'm done. That wasn't the case. So I was looking through the artwork, and what the artist actually did was they put the different types of arrows, different types of judgment, even the actual font in a single PNG file. So I was looking into a way to hack, the image to maybe do a mask, say, okay, I only want this rectangle area, only this subsection. Maybe if I can just make it read just part of it, try to set painted width, painted height, and none of that works. At the end, what I just ended up doing is writing a quick script that would go through and say, okay, these pixels are for this image, these pixels are this image, and just split the image up. And that was the only way I could actually make it work. But once that was done, well, then I was actually done. The other problem was that StepMania was using essentially bitmap fonts. It was using these characters to say, okay, this is A, this is B, this is C. And QML doesn't have an easy way to kind of translate that using the text element. Yeah, there is a way you can do this really stupid like JavaScript, okay, go through every one of them and try to convert each character to an image and try to dynamically load them, but that would have taken a lot of time, and as I'm going to explain later, the JavaScript sucks. So a lot of people are asking me, how long did it actually take you? Actually, it didn't take too long. So one of the ideas is I wanted to actually use the real DWI files or .sm files. These are the files that say at what time, when should the user actually push down on which arrow. Unfortunately, they don't actually say at this millisecond, this arrow, this millisecond, this arrow. They say, okay, this is the beats per minute. You have a quarter note, half notes, sometimes 1/16 note, and here's a measure, here's two measures. It actually got really complicated really easily. I actually had one of my coworkers try to actually do all of that part by himself. He tried to use regular expressions, but that didn't really go too far because it doesn't handle the case of different types of measures. If they say, okay, if there are this many notes per this measure, it's really hard, and it's really a problem with the format itself rather than this kind of proof of concept. I could have, just made my own format or convert this one to an XML one, but I didn't want to waste a lot of time, and the odd reality is that all these files are on the internet. They're all DWI files, .sm files. If you want to get these rips from, the PlayStation version or rips from the PS2 version, they're all going to have .dwi files, and that's what people really want. So you're going to have to write some kind of parser, even if it requires cheating. So I spent a lot of time in just getting the JavaScript and the timing to work. And then the rest of the QML was actually pretty easy because all the animation was kind of straightforward, all the video was straightforward, the audio, just an audio element. That was actually the easy part. So I want to talk about a few hacks I actually had to do to make this work. So I did not expect the life bar to actually be an issue. Life bar just says, if you have this much left or you screw up this amount, if it goes down to 0, it's game over. First of all, it's a horizontal gradient. Now, horizontal gradients has been around since ages, but QML says, nah, you don't need horizontal gradients. You want vertical gradients. And you're like, no, I do want horizontal gradients. Well, it's going to be a lot of performance hits, so no, not really. So I had to come up with some sort of way. Maybe if I use the rotation and anchor.fill, but that doesn't work because, hey, QML is declarative. You don't know what property is going to be set at which time. So I had a weird stick that was, sticking out, and it just looked terrible. So the hack I ended up doing was the actual image mask on the bottom left. I set the clipping to be true, and then the inside gradient, the width and height were the same as the life bar itself. So outside of the life bar, you don't actually see the gradient, but it's actually a big, giant rectangle, and you only see that part of the life bar. And also had a a black rectangle that would actually increase in size that's over this gradient to make it look like it's shrinking because, yes, there are lots of performance issues, and it gets really confusing when you're saying, okay, I want to move from X here to X there, but rotations by 90, that's after that, and it gets really confusing. I did not at all expect the biggest problem would be arrow handling. I thought, okay, let me just do some stress tests, get the arrows up, everything's really smooth. Okay, I'm going to actually start playing the game, on left, on right, on up, on down. And the problem I had was that every time the user actually hit some sort of key, the entire game would freeze for a second. I was like, what's causing that? So in DDR, there could be up to like 400, maybe 500 arrows that's in the entire song. Doing a simple iteration of like, is y less than 64, it's actually pretty expensive. Why is that? If I had these items as like normal JavaScript objects, doing 400 integer calculations, that doesn't sound like it's something that would be an entire second. So I did some more research. Turns out that when you have a component, like an actual QML component, and you're doing something like simple as, just get me the X value or Y value, it takes a long time because these things are not natively JavaScript. These things are natively QML. Yes, QML is JavaScript is part of QML, but that doesn't mean that when you're doing something like .x, .y, you're not going to hit some sort of performance issue. So the way I ended up fixing this problem is essentially seeing only a subset of the error array, only the ones that are on the screen, because obviously who cares about the arrows that are gone, who cares about the arrows that haven't shown up yet. I just want to see if the user got an arrow that might be good enough. And as I said before, there is no collision detection, so I can't say, okay, on arrow gone or on arrow past this level, do this, because that would be too costly. So what I ended up doing is I had a timer for the first part saying, okay, every 1 second or 2 seconds, just look at the array, see which ones are already passed, get them out of the array. Just stop their animation, get them out of the array. And this is the code that I used just for a timer. All I had is logic.remove dead arrows. And then I had it actually go through, say, okay, if it's not this, and also if the person actually didn't hit on it, say, okay, then your life bar goes down. And then after that, when it's actually iterating through the array, it says, okay, when am I beyond the screen already? If I'm beyond the screen, stop actually looking through the array. So now it's like, about 30 milliseconds, 50 milliseconds each time the user actually hits something. So that's, it's much better, but I'm sure it can be improved even better. Sometime next week, I'm actually going to post all this code on Gitorious, open source. So I'm sure somebody here can come up with a much better solution, and patches are definitely welcome. So I know QML is a very new language, so I don't want to say I am the expert, but here's just some random tips that I think you should take at least for your own projects. These really helped me out. First one is don't be afraid of that new file option. So, you're making your elements, your file's now 500 lines long. That's about the time to think about that new file option. Now, yes, you have to right-click, new file, dialog, type in the name. Yes, it's a pain, but in the long run, it's really worth it because before you know it, you're like, oh, what would be awesome? Do this animation. Oh, it should have this kind of gradient. No, it should have this kind of rectangle. And your 500-line code will turn into 5,000 lines of code. And you're like, oh, I have no clue how any of this works. So yeah, even for this simple application, you have like 8, 10 different QML files, but you can kind of, if you know where the files are, you'd say, okay, you have your main, these are a subset of these. It's kind of straightforward. QML is fast, except when it's not. So don't expect the JavaScript or QML to optimize every last performance issue. You're going to have some sort of case that's not going to be in your favor. So try to minimize on the JavaScript. Try to find out where the actual QML actually is really fast and try to use that, because you want to be like water. You don't want to go with your headbutt the problem and then you're just going to get a big headache. You want to be going around the problem rather than against it. Try to put very little JavaScript in your QML files. QML is nice about having a .js file that's completely separate, has its own logic, that's completely outside of the QML file. Definitely use that feature, because before you know it, you're like, okay, it calls this function, but where is that function, first of all? And then you're having namespace issues. Is it that component's function, or is it that component's function? It can get messy really easily. So it's best to actually put it all into a single file. So when you have, let's say, on key press up, call this function, just have it call, what I did was I have a logic.js, and I just used a logic namespace. So I said logic.handle left, logic.remove arrows. Just very one-line function, very quick, easy one-line functions that would send it to your JavaScript file, and that does all the dirty work. And now it's time for a demo. So I'm looking for a volunteer. So there is a prize if you participate. So can I have any kind of volunteer? Don't be shy. Don't worry. I made it very easy, and we're all going to cheer for you. It's a very useful prize, I can tell you that. Anybody? All right. All right. A little bit, but as I said, I made it easy enough that anybody can do it. All right. Let me just